Welkom bij een nieuwe aflevering van de Nederlandse Kubernetes podcast. De podcast over Kubernetes voor iedereen. Ik ben Ronald Kers en ik zit, zoals altijd, met...
de solutions architect van ACC ICT, Jan Stompost.
Oh, daar ben ik even stil van. Die is nieuw. Heel goed, Jan.
Ik doe mijn best.
Heb je het naar je zin vandaag?
Ja hoor, is hartstikke leuk.
Ja, mooi. Nou, ik heb het ook helemaal naar mijn zin. Want we hebben net een talk gezien dat ging over retro computers. En Nintendo. Beetje jammer dat Sega niet voorkwam. Maar goed, daar gaan we nog even over vragen.
Ja, maar ik vind Nintendo beter.
Ja, nou ja, goed. De console wars are over for a long time. The real console wars are over for a long time.
De PlayStation 1, hè?
I would like to introduce David Sturs. Pronounced it correctly? I lost my German accent along the way.
How you spell it in English? I always struggle as myself.
Okay.
Stairs.
Okay. Welcome, David. Can you please introduce yourself to our listeners?
Sure. I'm David. I'm from Germany and I'm 41 years old. I used computers since I'm 5 years old. So my father studied informatics in the very, very early days. And he set me in front of a computer. Back then it was an 8086 with 4 megahertz. So I started with PC, learning DOS commands to start DOS games. So that was my motivation. Did a bit of Pascal programming. And then at some point my older sister bought a Nintendo Entertainment System. So and this is where my love to game consoles started. So all my friends also had Sega consoles, but I'm really on the Nintendo track. Yeah, so it's on Sega.
It's fair. They have both their good sides and their bad sides, but
I like Mario.
At least there's a passion for the gaming of that time, you know. And I think that's a good thing.
Yeah. Nowadays, I'm a solutions architect, so I have a long history of cloud computing, like 16 years. So I started with AWS as an early adapter back then, and I've experience with other hyperscalers like Azure and GCP. I also have experience with Asian clouds like Alibaba, AWS China, and Azure China. This is where I spent, let's say, most of my career in cloud computing in different industries.
Oh, nice. Here at Edgecase, you had a talk going retro. What we can learn from old game consoles for the modern art of running Kubernetes at the edge. Could you please explain what you were trying to say during that talk?
Yes, sure. So, having played retro game consoles for a long time, then I looked into how the games were made and how the boundaries were pushed just by cartridges that got add-ons like CPU and coprocessors or sound chips on it. Also, I was curious as I'm a software developer by education, how these games were made. So I learned this assembly language, which I also learned during my education, a different dialects. I was really fascinated how what you can really get out of a 1.47 megahertz console, how much fun and all this. And while looking at the game console scene and playing it at home and really going really deep there, I was, as I said, like working in cloud computing, and with cloud computing is a bit the opposite, because I think one of the key selling points of cloud computing is things like never pay for idle, scalability, but it also scales your pocket, right? So I've worked in the FinOps Foundation, which is educating people on cost allocation, cost optimization, especially for cloud computing. And I've seen many companies that wasted a lot of money. So throwing money as a problem. And that was, for me, also the opposite of my insights that I got from the retro game console and the fascination. And I mean, if you do cloud, you also come along when it comes to Kubernetes at some point. So I used cloud before Kubernetes. I used Kubernetes since 2016.
Which version was that?
I would also need to look it up. But it was released 2015, right? I think it's quite early. So Yeah, also containers. So I was then fascinated about the containers because the high density and the bin packing and all this, that already reminded me on retro gaming, so that you really make use of the resources that you have. That is what I also found very interesting. And a combination with the FinOps Foundation to really optimize. You can only optimize what you really understand, also when it comes to constraints, right? So like performance, costs, and reliability. This is something that you always need to balance, and you are just a good engineer if you really know what you're doing. And this is what I also found really fascinating.
Yeah, because if you work within restrictions, you need to be very creative how you program. If you look at the odd consoles,
Yes.
what the NES was like 1.4 and 1.7 megahertz, and a small size of memory. And if you could see what tricks they used,
Yes,
to manage to provide to show the things on your screen, it is really impressive. And I think that's also, of course, in the cloud. If you always scale up, it's not optimizing the process. If you put more restrictions on it, you have maybe are forced to more like work in a restricted environment and be more creative to optimize the process.
The problem is it has to run everywhere nowadays. Then you've got an NES. We know the NES. Awesome. It's a 8-bit. And you know the thing inside and outside, but you couldn't run Mario on a Sega Drive.
The Master System.
Well, the Master System. But that's and nowadays you have to run your workload on everywhere. So that's a big difference.
that's a big difference to a console. So the portability of Kubernetes is definitely helping in that case. And when it comes to edge computing, which the talk is also about, like I wanted to connect, we had Edgecase, so we're talking about Kubernetes at edge. So and then I worked now very much focused in the past, I would say 12 months on edge computing use cases in stores and factories and other locations. And there I recognized when speaking to the people, you have a lot of constraints, also capacity. So people buy, for example, for a store servers, but they want to use them for 5 years. And then there are like, let's say, non-optimized software running there, and the capacity is just exhausted. And if you want to add more stuff, it's not possible. And another thing is, as you talk about portability, or let's say it needs to run everywhere, is also
It's your workload can be run. You can run that workload in Google, in Azure, and everywhere. And Kubernetes help.
But do you have the same performance everywhere?
No, probably not, because the machines are different. But it still has to work everywhere. And with a Nintendo game, you've got a Nintendo console, and it has to run in Nintendo console, so you can optimize for that Nintendo console really, really good. But now you have to think about what kind of workload. Your workload differs. So a game computer is very
A closed ecosystem.
a really closed ecosystem. You've got 1 or 2 players, or 2 players on the NES. So that's your workload also. If you think about now applications, you've got a workload that can differ because you don't know how many people are coming on. So the workload is more difficult, I think. And
okay, gotcha. Yeah, okay. The scalability is important for some, but not for everyone, I would say. I mean, if you have like, let's take a very simple example, an e-commerce shop where people are coming, buying your goods. This is the most easiest example because people can easily relate to this, that if the shop is down, you cannot make money with it. And also people not shopping during the very late night in their own time zone, right? So if you have a global shop, you can even split it across regions. So what I want to say is you have a very predictable pattern. So
no, that's not predictable.
it is. I mean, if you have a curve where people are usually buying, so I also worked for IoT platforms.
Yeah, but probably you have that's hypothetical. Great, you have a product that goes on TikTok, and then your curve goes out of the way. Then you've got a problem.
Yeah, that's true. But if you have a really high dynamic website, that this is behind the TikTok post, but I've built many platforms, and like high dynamic websites are very costly because I need to process each and every user's request. Okay, that is true. But if you build your platform properly with like caching your website and just delivering a static HTML from a CDN, it is super cheap. It is super scalable because it's what CDNs are made for.
Yeah.
And I mean, I've built not platforms for every industry, and I totally get that the scalability is a really important feature to offload. But from my point of view, often you can predict that, and you can also work with a certain baseline in a more constrained environment because it's just more cost efficient. So that means hybrid clouds is on the rise, if you ask me. So people are moving away from public cloud at some point. So there are some very prominent examples, like the Basecamp guy, right, the Henderson, for example. Also Elon Musk shut down half of the Twitter infrastructure and threw out half of the people. I think it's still working, right? So it's like, I think it went too far with cloud computing. And that's why I think that cloud can also learn a lot from Edge. And Edge can learn a lot from Retro because they were first.
and now the circle is complete.
And the Edge is more similar than an retro gaming machine. Yeah.
To me it is, because I mean you are very close at the hardware, and of course you can do over provisioning with a lot of hardware up front that you then use, but this is exactly what the term hyperscaler is, right? So that it can be with lots of over provisioned resources. I mean, maybe you know the story, but this is the story that I know is that AWS is invented because of the Black Friday and the Christmas traffic. So AWS had to keep a lot of spare capacity for the Black Friday and the Christmas market, and they were thinking like, what do we do with all that capacity over the year? Yeah, before
We'll
Christmas, we sell it. Yeah, we rent it. This is actually the original idea of cloud computing.
Cool. I didn't know that.
No, we learn every day.
We learn everything. Yeah, that's awesome. And so
I remember what I wanted to say when I lost track. You
Yeah,
are
just
you are
go
cutting
ahead.
it properly anyway.
Yeah.
Good. So I wanted to say about the edge computing locations, the portability that you brought up with Kubernetes, that it has to run everywhere, or let's say it's a wish and it's a good idea to have a certain level of portability. And also talking about kind of the people are afraid of vendor lock-in, right? So Kubernetes addresses exactly this, but it addresses way more. Installing Kubernetes at edge makes a lot of sense of many reasons. For example, you reduce the amount of snowflakes that you have. Yeah, with edge computing, then you maybe have a Windows server here, then you have a hypervisor there. With Linux here, the one IT admin use this deployment script, the other one use this kind of automation. So it's really messy. It's also a risk for the entire company if only a few guys really understand how everything works. With Kubernetes, it's completely defined, the official documentation, and still you can extend it. It's not like you are restricted to use Kubernetes as it is, but I mean Kubernetes won the container wars and defined an API with the overall community that people agreed on how to deploy, how to set up a liveness probing and self-healing capabilities, and how you do this. This is all kind of standardized, yet you can extend Kubernetes very nicely. And I think this is the biggest advantage, these two things, portability, standardization on the one hand, and still you can extend Kubernetes. So it makes it super powerful. And I also once heard the rumor that some hyperscalers, not naming them here, they hate Kubernetes.
oh yeah.
It's not GCP, I can tell you, for sure not.
No, of course not. But why then do they hate?
I can tell you, because a cloud platform is a platform already. It's complete in itself. Kubernetes, there are some people that say, did Kubernetes throw us 10 years back, right? Why do they say this? Because Kubernetes is just a platform to build platforms.
Yep.
It's a pluggable something. You can call it a kind of framework, or let's say a platform where you have like storage and network. Everything needed to be developed. I mean, it's a spin-off of Borg, right? At Google. Google had Omega, then they had Borg, and then they open sourced Kubernetes 1.0. I think it was 2015, if I remember correctly.
10 years ago.
Yeah. And then it was 2014. True, the 10 years. And if you see, like, there's a nice documentary, right? The honey. There's a Kubernetes documentary that's of 2 movies at YouTube, and there you can see. Not sure it's true, but at least they showed. For example, AWS released ECS, I think a few months later when Kubernetes source code was released. And that shows also they were kind of afraid that people are moving away from AWS and using the container orchestration that the Google Cloud offers then. But they didn't release the ECS source code. It's not available yet. It's a proprietary service. And according to some people, AWS were not the biggest fan of Kubernetes.
It's the elastic container service, by the way.
Yeah.
Exactly, because everything started from the
And-
scratch.
And that's annoying, by the way, also. But it's my opinion. That's sorry.
Not sure we want to keep it in here, but this is what I heard, that AWS was super happy and they wanted to use their full platform end to end, which I can also understand. It's like what we all love, I think, when people have a Mac. You don't have a Mac, I don't know if you have an iPhone, so that the interoperability of Apple devices, right? People enjoying it at home, right? How you sync the files, your Apple TV and screen share and all these things, because they have a very close ecosystem. They keep it very strict, and you can compare this also to public cloud, so that you say we are nicely integrated. With Kubernetes, you installed a new platform inside an existing platform, here cloud, and then everything started from scratch. And look how much trouble people have with the integrating managed databases of public cloud with containers and Kubernetes. It's a big hassle, right? So like they needed to some people use Terraform to provision their Kubernetes cluster, and then they need to enter the YAML world and do the deployments in Kubernetes. You need to already learn 2 languages, right?
Yeah.
While if you stay with a cloud provider, you can use their infrastructure's code solely. Or if you go in, this is what I see also coming, that we will go more Kubernetes all in. I think the time is right for this.
Yeah? You think databases and everything stateful
Yes.
is ready to go in Kubernetes?
Yeah, we can do a whole episode only about the data on Kubernetes topic and stateful and stateless. But my prediction is that we will see way more adaptation of data on Kubernetes. Why is that? Because it's advanced a lot, and people are still afraid. Many people I think remember the early days of stateful sets and how awful it was, and they crashed the database, data was lost and all this. But I think it's really time to rethink, and because
But it's not the case of Kubernetes, because it's the case of databases. Because if you have a Postgres database, you need to think about clustering that Postgres database.
yeah, but you have mature operators. I think the most prominent and mature operator is the Cloud Native PG project, where they're not even using stateful sets, right? They have another logic built in that is a bit smarter than what stateful sets provides you with from a native Kubernetes standpoint. And the other reason is that people were putting databases into their workload clusters. They mixed it and they lost control, and maybe they were also not, always in control of what's going on. But nowadays, you could also think to split up a workload cluster where stateless applications living or your deployments are in, and you have maybe a data cluster. Because what I want to say is also that multi-cluster management became way easier. Not only the provisioning of multiple clusters, but also, let's talk about cluster mesh, for example, right? How you can join. You can segment Kubernetes clusters depending on the type of workload. Here, database also a workload. It's pretty much matured, but if you speak also to people that adapted Kubernetes for very early, many of them, I would say more than 5, if you ask 10, would say, no, the data on Kubernetes is not a good thing. But I really think it's time to revise that statement. And you can also watch the younger people, the newcomers.
Yeah.
They don't know the history, right? Maybe they have seniors in their company that says, no, we are not going to do this. But we will see that the young people that's coming to the Kubernetes and cloud native world, they don't have this.
They don't have those the legacy.
The legacy anymore.
No.
And they install cloud native PG. Of course, they also benefit from senior guys in terms of how do you do the segmentation. I call this also cluster topology and how you segregate all this. And I think it's it's time. Yeah.
It's time.
But about the hypervisors also, what we saw in the presentation here is also that you can leave out the hypervisor and just put Kubernetes on bare metal.
Yes.
You know? So I can assume that the hypervisor guys look at that and even we don't like that happening.
Absolutely. And but they have an answer to this, right? AWS has EKS Anywhere. This is the answer. GCP has Ansos for this, and Azure. It's not Azure Stack. It's Azure. I need to look it up.
Azure something.
Yeah, but that's for that's the cloud variant, or is that the on-premise?
No,
variant?
it's for building hybrid clouds. Remember?
It's installing your Azure AKS.
Azure Arc. It's called Azure Arc. So
Arc. That's we've heard about it.
Azure Arc, and you have NSource, and they admitted, like as I said, also I predict more hybrid clouds because people have the data center. If you do some research, there's still new hosting companies coming up. People are still building data centers, and not everyone is going to public cloud. Also, look at the European Union. The sovereign cloud movement is quite big, right? For governmental stuff, public sector, healthcare, financial services. They are not compliant if they use a hyperscaler. They could still do it. It's not forbidden for them, but they are looking for other options.
The Gaia X cloud.
Gaia X more specification to move data around, and it's more an abstraction layer. It's not a hosting, right?
It's not that good. Gaia X.
No, you can talk about OVH, for example, Ionos. You have Vultr, for example, in that space here in the Netherlands. In Germany, the biggest one is Stackit. So it's from the Schwarz Group.
ACC ICT has also a cloud.
Just not name dropping here.
Yeah, and this is why I see that we will see more hybrid clouds, and you then have also consistent stack, because you can still install Kubernetes in your data center and provide services there at the edge and in the cloud. So you have one ecosystem everywhere. You need less people, less snowflakes, everything a bit more harmonized. Also data on Kubernetes. And it also helps with it. So I see a really big future. For me, it's unstoppable. Two things: the hybrid clouds, to reuse what you have, be more efficient with it. Now we could also talk about sustainability and the whole carbon
That's
emission
the word I
topic.
was thinking about also.
FinOps is also heavily connected to sustainability, because if you save some of the costs and servers and, I don't know, move to other CPU architectures like ARM with lower power consumption, you're effectively reducing also your carbon emission footprint.
Cool. There's lots to think about already. And but back to the databases and what kind of database do you think is the best fit on Kubernetes?
There's no answer to this, because it really depends on the workload and the application that you are building. But I would say let's talk about web development. I would say with a NoSQL database and relational database, and maybe an object store, you can do a lot of stuff already, right? You don't need to have way more databases. So like time series databases, sure, in the IoT space, and there are many more databases coming out as we speak, right? Maybe you've heard about DuckDB or StarRox, like OLAP analytical database. Cockroach is not so young, but yeah, it's also there. People still using also Cassandra for certain use cases. So my personal preference, and I think it used to be a hidden champion, now I think it's a very visible champion, is definitely Postgres. So not only because of the license mess up of Oracle, what they did, it's really, Postgres has so many nice plugins. You can use Postgres, for example. You have a JSON output. You can kind of have a document-oriented database out of it. You have plugins, very funny, like PubSub, but more important in these days for AI use cases with RAG, for example, you have a vector plugin, so you can easily make a Postgres a vector database. You don't need to buy a specific vector database. There's a plugin for Postgres. Just to name a few good use cases.
Cool.
Cloud Native BG, again, is the best operator that I've seen for relational databases. So just use Postgres, check the plugin directory, have fun.
Before we go to the final question, I would like to ask, what's your favorite retro game? Because we haven't asked that.
I think it's Mega Man 2 on the Nintendo Entertainment System. That first comes
man
to
of
my
culture here.
That is my favorite one. The soundtrack and the levels, level design. It's
What's your order of the bosses? Which one do you start with?
so there's a natural order because they're easier to defeat if you then
I know.
consume their weapons. You start with Woodman.
But you can-
You need to start with Woodman. Otherwise, it's too tough to beat the first one.
Yeah, Metal Man is also easy to beat, and then you can easily beat Woodman with the sauce. But yeah, if you do the wrong order, you will miss the E blocks. You cannot reach them if you
Yes.
do the wrong order. So
Yes. Okay, look, you played a lot of Nintendo.
I
as
have,
well.
yeah. I know Mega Man 2 from memory. So
Yeah.
it's and then my nephews showed me Sonic the Hedgehog, and then it was done.
It's also a great game.
And that's a good game.
Yeah.
Yeah.
I think Mario is better.
Okay, but but that's maybe I should do another podcast about all the retro gaming. That's an idea. But the final question: if I would put a crystal ball here on the table, and I will ask you, what would you like to see in the future, or what do you expect in the future about Kubernetes? What would it be?
Yeah, I would like to see more adaptation of data on Kubernetes so that people build more distributed clouds and not give their workloads only to major clouds. I would like to see more decentralized world where data resilience and also workloads and specific services belongs to many people, yeah, and also the infrastructure below and not to only a few big player.
Yeah.
And
Cool.
I think that is possible with Kubernetes. Everything is there. And
It opens up a lot. Yeah. Okay. Well, David, thank you very much for joining us in our podcast. And
Thank you.
we're going to follow your development with your presentation about retro gaming very closely. At least I will. I would love to talk to you in the future about all the stuff you're doing. So,
sure. Thanks for having me here.
Thank you.
okay. See ya.